Polynomial equations. If you put polynomial in x equals 0, that's a polynomial equation of degree n. The real values of x that satisfy the equation are called the real roots of the equation or the real zeros of the polynomial. All right? The roots of the equation or the zeros of the polynomial. All right? So find the zeros of that polynomial. It's just asking you to factorize it, put it equal to 0 and solve. So there's your polynomial in x equals 0. Find the zeros. Find what x is. Find the roots. Okay, what can we do first? You haven't learned how to factorize cubics, but there is a common factor. Ready? X bracket x squared minus 8x minus 20 equals 0. So x bracket, it must be x minus 10. X plus 2 is 0. And therefore x is, what have you got? 0, 10, and negative 2. They're the zeros or the roots of the roots of the equation or the zeros of the polynomial or the x-intercepts. Right? But you won't see them call it x-intercept anymore. Show that this polynomial has no real zeros. Don't bother trying to factorize it. So what do? Use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, when we do the topic called quadratic equations, you're going to know that you can just do the discriminant. The only way this is going to have no zeros is if the b squared minus 4ac bit is negative, and you can't square root of negative. Doesn't matter what b is. Doesn't matter what a is. It matters what b squared minus 4ac is. So later you can just do the discriminant, b squared minus 4ac, and if it's negative, you can say, well, that's going to have no solution, the whole equation. So what's a here? A is 1, b is negative 1, and c is 4. Remember, a, b, c? So what have you got? Negative 1 is positive 1 plus or minus the square root of. Negative 1 squared is 1 minus 4 times a is 1, c is 4. Girls, it's better to use the brackets as opposed to the multiplication symbols. It's a bit cleaner. Over 2 times a is 2 times 1. So therefore x is 1 plus or minus the square root of what? Negative 15 over 2, which has no solution. So therefore there are no real zeros. All right? Now, this bit down here now, this is from Cambridge, worksheet 4A. For this polynomial, find the values of. It's just got to do with notation, this one. This is from worksheet 4A, question 10. For the polynomial, so a minus 4 is the coefficient of x to the power of 7. 2 minus 3b is the coefficient of x cubed. And 5c minus 1 has no x term attached to it. It's constant, all right? It says find the values of a, b, and c if it is of degree 3. So if it is of degree 3, then there must be no degree 7 term. The degree is the highest power of your polynomial. So if it's degree 3, so each of these is an independent question, all right? So if it's degree 3, then we do not have, so a, for degree 3, then we've got to say that a minus 4 would have to equal 0. Do you agree? That means that a would have to be 4. Now, if it's degree 3 as well, 2 minus 3b can't equal something if it's degree 3. It can't equal 0. Otherwise, it's going to be the 0 polynomial. So if 2 minus 3b equals 0, then it's not degree 3 either. So it's not degree 7 because a minus 4. So for degree 3, a minus 4 would have to be 0, a would have to be 4, meaning that x cubed is your highest power. All right? So for degree 3, we also have to say that 2 minus 3b can't be 0. In other words, b can't be what? 2/3. Okay? And C, I don't think it matters what C is. All right? C is all real numbers. It could be anything. Doesn't matter what C is. Positive, negative. All real whole numbers. Oh, it could be a fraction. Yeah. All real. I'll just put integers. I'll just put all real integers. Okay? Integers are positive, negative, or 0. All right. B. If you want degree 0 polynomial, degree 0, what has to happen? You've got no x to the power of 7 term and no x to the power of, that means no x to the power of 7 or x cubed term. But it's not the 0 polynomial. You will just have a constant term. So what does that mean? We already know some values. Therefore, A must be what? If you want no x to the power of 7 term, tell me what A's got to be. 4. If you want x cubed term to be 0, tell me what B has to be. It has to be 2/3. But I just want degree 0. I don't want the 0 polynomial. I still need to have a constant term. So that C can be any value except for one value. So what I want is that 5C minus 1 can't equal 0. Otherwise, I'll have the 0 polynomial where everything's 0. So what does C have to equal? Or C can't equal 1/5. In other words, C can be anything except for 1/5. Any other value apart from 1/5 gives me a degree 0 polynomial. It'll be just a constant term. C. If you want degree 7 and monic, that means that A minus 4. So degree 7 and monic, doesn't that mean that A minus 4 has to equal just one thing? What? 1. That's it. In other words, A is 5. It doesn't matter what B and C are equal to. So B could be all positive integer, like anything, all real X, or all real. I shouldn't have put probably integers here because I should just put all real. C being an integer, C actually more than likely is going to be a fraction, you know. Can you see? Then the whole thing will be an integer. So I'm just going to put all real rational numbers. Rational numbers are fractions. Whole numbers are also rational because the whole numbers, say 5, can be 5/1. -5 is -5/1. So that needs to be all real rational numbers. So if you want degree 7 and monic, A minus 4 has to be 1. In other words, A has to be 5. B and C are equal to all real rational numbers. They can be fractions. They more than likely, like you could have, for example, 2/3, you see, for B, which gives you 2 minus 0 is 2 is the coefficient of x cubed. All right. I'm not talking, the coefficient itself will more than likely be a whole number, but the B and the C bits have to be fractions for some of them. Like it could be fractions. Now for D, if you want the 0 polynomial, that means that there is, what does that mean? That there is no x to the 7, x cubed, or constant term. There's nothing. So how does that happen? The 0 polynomial, if you look back at the sheet we did before, is where each coefficient is 0, even the constant term. It's different to degree 0. Degree 0 has a constant term. The 0 polynomial has no terms. It's every term 0. So doesn't that mean that A minus 4 has to be 0? So A is 4, isn't it? B is 2/3. But we need C to be, it has to be 1/5. But we've already worked it out before. So please, 0 polynomial and degree 0 is different. Degree 0 still has a constant term. 0 polynomial doesn't have one. Okay? Polynomial whose degree, leading coefficient, and constant term. Now it's got to be monic polynomial. So you want leading coefficient has to be 1. So write down the monic polynomial. That means it's got to be 1 x to the power of something, whose degree, leading coefficient, and constant term are all equal. Now, they've all got to be equal to 1. Do you agree? So it's 1 x to the power of what? 1 plus. So that's your leading coefficient's 1. The degree is 1. I haven't put the constant term. What's that? 1. So what's that? X plus 1. Your polynomial in x is x plus 1. Okay, so in some questions, they'll ask you, they'll give you hints about the polynomial, about its leading term, about its coefficient, etc. 4a, question 9. Find the values of a, b, and c if a times this x plus 2 squared plus b times x plus 3 squared plus c times x plus 4 squared equals this. Just looking at that, what do you think we need to do to the left-hand side? I think we need to expand it. So your left-hand side is a bracket x plus 2 squared plus, it's different. It's not a plus 2 in the brackets with the x on the outside. It's not. So we're going to have to expand it. So let's start. What have you got? I keep that a at the front. What have you got? X squared plus, come on, expand it. It's a perfect square. X squared plus 4x plus 4 plus b bracket x squared plus 6x plus 9 plus c bracket x squared plus 8x plus 16. Now what I want to do, I'm going to put all of the x squared terms together. I mean, I can take another row and expand, or I can say, oh look, I will, I'll just, you don't need to, but I'm going to multiply through by a, then I'm going to multiply through by b. Well, you don't need to if you can keep track of things. If you feel that you're not going to keep track of things, notice I'm putting the x, so I've got 8cx, one sec, got cx squared plus 8cx. Do you know why I'm not putting the c at the end? C is the coefficient of the x squared. 8c is the coefficient of x. Because when you're writing a polynomial, you want something x squared, something x constant. Something x squared, something x constant. I don't want the b behind the x squared. I don't want this to be 6xb. The 6b is the coefficient of the x. I need the constant term, you know the x squareds, I'm underlining them, ax squared plus bx squared plus cx squared, isn't that a plus b plus c times x squared? Isn't that the coefficient of the x squared? Plus, let's look at all the x terms underlined in pink. So, the coefficient of the x term is 4a plus 6b plus 8c times x. Oh, well, x, the coefficient is that bit. And the constant term is what? 4a plus 9b plus 16c. Now, you know what we've got here? You're not going to like it. It's not a cubic. You've got 3 simultaneous equations which we need to solve, so we're going to need more room than this. So, what have we got? So now, let's equate the left-hand side with the right-hand side. Tell me what a plus b plus c equals. No, it doesn't. This, a plus b plus c, is the coefficient of the x squared. Looking at the right-hand side, that equals 2. A plus b plus c equals 2. Can you see now why we've... So that's equation 1. Equation 2, 4a plus 6b plus 8c equals 8. You know what we're going to do with that? Let's halve... Oh, no, we'll leave it. We'll leave it. Leave it. You know why? Because the third equation has a 4a as well. And then we can just multiply equation 1 by 4 in a minute. Let's look at our third equation. 4a plus 9b plus 16c equals what? Good. Now, let's make all the a's the same coefficient. that means I just need to multiply equation 1 by what? Okay, good. That's why we kept the others. So we're going to go equation 1 times 4, and we're going to call that equation 1a. So we've got 4a plus 4b plus 4c equals 8. I'm going to call that equation 1a. Now we can solve. All right. Adding or subtracting, girls? So we want to work with 2, 3, 4, 1a. So let's do, I don't mind what, let's do 3 minus 2, equation 3 minus 2. And what do we got? 3 minus 2, 4a minus 4a, 9b minus 6b is 3b, 16c minus 8c is 8c, and 6 minus 8 is negative 2. We'll call that equation 4. And then we can also do, I want to do 3 minus 1a so I don't get negatives. 3 take away 1a, equation 3 take away equation 1a. What have you got? 4a minus 4a, 9b minus 4b is 5b, 16c minus 4c is plus 12c, 6 take away 8 is negative 2. That's equation 5. Now we're just solving those. All right, looks like it's going to be equation 4 times. Equation 4 times 5 and equation 5 times 4. Yeah? Equation 4 times 5, 15b plus 40c is negative 10. We'll call that equation 4a. Are we good? Equation 5 times 4. No, I've made a mistake. Times 3, sorry. Times 3. Equation 5 times 3 is 15b plus 36c equals negative 6. That's equation 5a. Now what are you going to do? Subtract. You can do 4a minus 5a. So equation 4a minus 5a gives us 4c equals negative 10 take away negative 6. Minus negative 10 take away negative 6 is negative 10 plus 6. It's negative 4. That means that c is negative 1. Substitute that into whatever looks nice, maybe 4 or 5. Sub in, I'm going to put it in 4. We've got 3b plus 8 times negative 1 is minus 8 equals negative 2. So b is it 6 on 3? It's 2. B is 2. Because I put, 3b plus 8 times negative 1 is minus 8. Is negative 2. Take that over, you get 6 divided by 3. That gives me 2. And now you can put b and c into equation 1. Will do. So sub c is negative 1 and b is 2 into equation 1. So we've got a plus 2 minus 1 equals 2. And so a is a plus 1. Isn't it? No, it's not. Yes, it is. Yeah, it is. A is 1. So there you go. Find the values of a, b, and c. So a is 1, b is 2, c is negative 1. We did need a lot more room than that. But it's just an application of solving, that is a 2-unit concept, solving 3 simultaneous equations with 3 unknowns. Okay. Question 12a from that exercise. Show that if a polynomial in x is given by a x to the power of 4 plus bx cubed plus cx squared plus dx plus e, if it's even, then b equals d equals 0. What does even mean to you? That function of x equals negative x. So, for even functions, that's all we know. I mean, you're not going to be able to sketch it, are you? We know that the function of x equals function of negative x, or p of x. Let's put p because we've got p's instead of f's, all right? We know what p of x is. I'll write it out again. P of x is ax to the 4 plus bx cubed plus cx squared plus dx plus e. What's the p of negative x? I mean, you can do the substitution. A, negative x to the power of 4 plus b, negative x cubed plus c, negative x squared plus d times negative x plus e. Notice I'm not using multiplication symbols. It's best to use the brackets. Otherwise it gets too messy. You won't know what's a times or a plus or what it is. So what have we got now? Haven't you got a x to the 4? Will the next one be a positive or negative term? Minus bx cubed. Next one, positive or negative? Plus cx squared minus dx plus e. Now, we know that for even functions, p of x equals p of negative x. I probably should write that down here. Okay, so p of x equals p of negative x. So we'll put p of x equal to p of negative x. So we write a x to the power of 4 plus bx cubed plus cx squared plus dx plus e is equal to, and then we write the other one out, ax to the power of 4 minus bx cubed plus cx squared minus dx plus e. And now we solve that. Now if I want to solve that, I'm going to take everything over to the left. Got it? What will happen with the ax4s? They'll cancel. Cx squareds go, and so do the e's. When I take the e over, you get e minus e 0. So basically what I've got is bx cubed plus bx squared, got it? Oh, sorry. Plus bx cubed plus dx equals 0. Now, isn't that 2bx cubed plus 2dx? 2bx cubed plus 2dx is 0. How do I solve this? Factorize. Take out a 2x. X squared plus, no, not x squared, bx. 2x, what have I got? 2x. I've got bx squared, got it? Bx squared, yeah. Plus what? Plus d equals 0. So therefore, doesn't 2x equal 0 or bx squared plus d equals 0? So I need some room. So therefore, 2x is 0 or bx squared plus d is 0. That means that x is 0, but it's this that I need to solve. X squared equals, this is not good. X squared is what? Negative d over b. Now, you can't get x squared is a negative. If that leads us to a bit of a dead end, right? What we could do is come back here, see this, where I put everything to the left and tried to solve it. My other option from there is to do the following. So I'm going to come up here now from there. And I'm just going to leave the x cubes on the left. Bx cubed plus dx equals negative bx cubed minus dx. In hindsight, I should have done it like this. Now, you know how in the question before we're comparing coefficients? So looking at the coefficient of x cubed, doesn't b have to equal negative b? So going from there, instead of doing this, because that's a bit tricky, the only way this will work is if b, wait, if they're equal, you still can't, yeah, that's just not helping me, right? It's not leading me anywhere. So best thing to do from here, let's just keep our x cubed on the left and these x cubes on the right, etc. The only way that that left-hand side will equal this right-hand side is if equating coefficients of the x cubed. So if we equate, so we say equating coefficients. In other words, we look at the coefficients of x cubed. Don't they have to be the same? Equating coefficients, you'd have to have the b equals negative b. that'll, and D will have to equal negative D. Yes? Now the only way that that will happen is if if they're both 0. How are you going to get, look here. Didn't we say here that the A plus B plus C has to equal 2? Because they're the coefficient of the x squareds. Look here. The B has to equal negative B. That never will occur. If B is 1, B can't be negative 1. Like, it's got to equal the same thing. That'll only happen if B is 0. The only way that B can equal negative B is if B is 0. The only way that D can equal negative D is if D is 0. So equating coefficients, B equals negative B, D equals negative D. This only occurs if B is equal to D, which equals 0. And same thing here as well. This will only occur, so this will only occur, it won't occur if B equals D equals 1, or B equals D equals 2, or B equals D equals negative 1. That'll only occur when B equals D equals 0 as well. Do you get it? X squared is 0. Yes, X is 0. Gives you a solution. So that's what they're trying to get you to show. That this will be even when B equals D equals 0. In other words, it's even. Guys, you know it's even when there's only even terms. Do you remember? That B is 0 and D is 0. Like, if I gave you that polynomial 2x to the power of 4 plus 5x cubed, you already could tell me that's not going to be even, because you're not supposed to have the x cubed term and you're not supposed to have the x term. Do you get it now? How it makes sense? See, do you think something x to the power of 4 plus something x squared would be even? It is. Because when you substitute your x and your negative x, you get the same answers. The problem is the odd terms cause it not to be even. So if this is going to be an even function, I don't want an x cubed term and I don't want an x term. But this is how you're going to have to set it out. Okay? Now, same thing here if it's odd. Do you want to just do this one? All right, so let's just do question 12b. Show that if it's odd. So what are the rules for odd? Yeah, so let's just do P of negative x is, can we just put what it's going to be? What's it going to be? Negative ax to the 5. Won't this one be still plus? Bx to the 4 minus cx cubed. Yes or no? Because I'd substitute plus dx squared minus ex plus f. That's what P of negative x is. That's what P of x is up there. If you substituted x as a negative 5, this would be negative, and the even ones would be positive. And then negative P of x is just a negative in front of each term. That's what negative P of x is. So 4. Yeah, everything's negative. Oh, no, it's negative of the function. You just put a negative bracket function. We know that P of negative x equals negative P of x. In other words, that equals that. So negative ax to the 5 plus bx to the 4 minus cx cubed plus dx squared minus ex plus f equals negative ax 5 minus bx 4 minus cx cubed minus dx squared minus ex minus f. Now, we're not going to take everything to the left because that doesn't work. So, if I did, you know, the ones that are the same cancel. Agree? Leaving us with bx to the 4 plus dx squared plus f equals minus bx to the 4 minus dx squared minus f. Now, the only way that this left-hand side is going to equal the right-hand side is by comparing the coefficients of each term. So, equating or comparing, so equating coefficients of, you know, the x to the 4, x squared, and constant terms. So we're equating coefficients of everything. We have to get that b equals negative b. You get it? That's the only way that the x to the power of 4 terms will be the same on both sides. And we know that d will have to equal negative d and f will have to be negative f. Yes? And this will only occur when they're all 0. This will only occur when b equals, when they're all 0. B equals 0, D equals 0, F equals 0. In other words, B equals D equals F. So if you get a bit confused, what we are looking at each one separately. The B is 0, the D has to be 0, the F 0. That's why they write B equals D equals F equals 0. They're just all equal to the same thing. Okay? All right.